Okay, looking at this limit, we will direct sub right off the bat. And if we want to do that just to see what the number is, we can probably do it in our head. What's the numerator going to be if we plug in a 2? So 2 squared is 4 plus 6. So I think this is going to be 10 over 4. And then this part may annoy you or not. I don't know. Does it bother you that we're at 10/4? Good. Don't. I'm not going to simplify it because on the AP test, we don't have to simplify answers. In fact, if you simplify stuff, all you're doing is making it more likely that you're going to make an error, a silly little math error, and get the problem wrong. You're welcome to simplify it, but on the AP test especially, don't. Deal? Okay. So what if we wanted to verify this and make sure that the properties work? Is there any property, or rather, which properties do you guys see that can apply here? Okay, talk with your neighbors. I'm going to call on somebody in about 15 seconds, so make it a quick discussion. What property will apply here? All right, so let's see here. Our list, I don't remember how many people are in here, but number 3? I don't have my list beside me. Is there a phone in number 3 today? David, you always get the first one of the day. That's bizarre. David, what property do you see first? You see division. Now, when you say division, are you thinking the limit of the top over the limit of the bottom? I am not. And here's the reason. I like that you guys see the division, but am I dividing by a variable? No. So I'm dividing by a constant. Dividing by 4, is that like multiplying by a constant? Hey, check it out. We have a constant multiple. 1/4 times that limit as x approaches 2. Because what can we do with constant multiples if you check your rules yesterday? So you can keep them, or you can move them out to the front. And then dividing by 4 is the same as multiplying by 1/4. So what I've done is I've just pulled out the 1/4. So that if I were to push this back in, do you agree that, Addison, if I do this, it's the same thing? I'm just taking that constant multiple out. And I'm viewing it like that instead. That makes sense? Does it really?
Well, why are you taking something out with no variable left?
Because so there will be variables, but if we had to deal with this limit that's kind of ugly to begin with, or if and we're just practicing with these properties just to make sure we have them, if we could deal with that limit with a fraction that's gross, or we could deal with this limit where we take the 1/4 out, which one feels more nice to you? And it might not be either of them, and that's okay. But I think that if I get to take a limit without fraction stuff, it feels a little nicer. You agree? Okay. So that's like the only reason we're just practicing to say, look, we can break these things down. Is there another property that we could use in this? I have the limit of what's happening here. So I don't have a constant in here because a constant just wouldn't have an x on it. But I do have the limit of what's happening between those. They're adding, but we don't say they add. It's a sum, right? So the limit of a sum is the... Good, Matilda. I would like to say good job, everyone, but okay. So the limit of this can be written down or broken down as the limit as x approaches 2 of what? X squared plus the limit of 3x, right? But before I write that, when I look at 3x, is there anything else I can do to it? Yeah, let's constant multiple. Let's get that 3 out there. 3 times the limit as x approaches 2 of x. Now, we are going through this like in a not very efficient way, just to practice with the properties. Once we're here, we could even go one step further and say, hey, if this is squared, then the whole limit is squared. But I think we're at a nice place where we could just direct sub. We're expecting 10/4. Let's see if that's what we get. If we do direct sub at this point, what would we get for just this first limit right here? 2 squared is 4, plus, what would this limit be? 3 times that's a 2, and that'd be a 6. Hey, did we get the exact same thing using all those properties? Yes. Is it useful to use those properties on a problem that's easy? No. But I don't think that every problem is going to be easy. Okay, I want you guys to work this one in your notes, but you're going to do it in that collaborative way. Everybody can write, everybody can talk, but I do want to throw you a curveball here. Okay, so we started with this one. This is what we did yesterday. Now, not all limits are going to be direct subbable. With that in mind, you should always try what first? direct sub. It should always, always, always be your first attempt. Now, unfortunately, we get some weird stuff. So let's look at one more. I want us to deal with the limit as x approaches 3 of, let's get crazy, we're going to have a lovely fraction again. We have x cubed minus 9x all over x minus 3. Okay, for this, we're going to try our first step together, and don't shout it out. I'm going to call on somebody random here. 12. That must be you. Are you 11? So there's only 11 people in class then, because no way anybody has a last name with a Z? Okay, number 8. Today's a drop day, like if you want to change classes. 8. Okay, Matilda, what's the first thing we should try? Okay, let's try it. What's the numerator? What's 3 cubed? 27 minus what's 9 times 3? Okay, so we get 27 minus 27 is 0. Okay, that's not bad yet. That's not an issue. 0 in the numerator is not a problem. Okay, what's the denominator turn into when we try direct sub? 0. Okay, ears wide open. We're not going to write this, but we're going to see this over and over. Normally, you're not allowed to divide by 0. We all know that, I hope. Can't do it. There's one exception. You can't divide by 0 unless there's a 0 up top. Now, this is a calculus rule, and this is what makes calculus so weird. We are not going to say that this is undefined. That is not what this is right now. This is in what's called an indeterminate form. This right here is a sign that we get to do some more work. We get, not have, we get to do more work. Now, what I mean by that is we need a way to deal with this such that that problem doesn't exist. So there are a lot of things that we can do. And we actually did this in, I assume we did it in Algebra 2, but we definitely did it in pre-calc. Did we ever have a rational function where something divided out? Do you remember what that told me was happening? If something divides out, it's what? So, you said whole. If a factor divides out, there was a hole at the root of that factor. So if we can find a function that agrees at every other point except this 3 because it's undefined there, then we'd be okay. In other words, if we can factor this and somehow get an equivalent expression where it doesn't break at 3, then we're in luck. We're looking for an equivalent function, and we're going to use the F word to do that. We are going to factor. So I don't always annotate super clearly, but we are going to factor and rewrite. Like, that's our goal here. Factor, and instead of just saying and rewrite, which is fine if you want to, I'm going to say factor to remove 0 over 0. Like, we're just trying to get rid of this. Now, really important, I'm kind of crazy with notation stuff, really crazy with notation stuff in this particular situation. Until you actually take the limit, you have to have the limit symbol. You can't just say equals and not write the limit stuff. I know it's tedious, it sucks, but you have to include it. The second that you actually do plug something in, you do the limit, then you don't have to write it anymore. But there's no way around it. So let's see what we can come up with. This is the limit as x approaches 3, and I'm going to use larger parentheses. How on earth can I factor this? I can't take out x to the third. I can take out an x, and what does it leave behind? Okay, so I need a choice from everybody because I agree with you. Can I just factor this here now also? Okay, so instead of adding an extra line, how on earth will that other piece factor? X minus 3, x plus 3. Okay, and that's all over x minus 3 still. All right, Christine, I think that you have this here. What am I going to divide out? Okay, I'm not going to bother rewriting this line without those because I crossed them out. But I want everybody to really grasp what happened. If we were to graph the original function and this one, they look the exact same, except the second one doesn't have a hole in it anymore. We've divided the hole out. It's disappeared. It agrees everywhere but that. So if we look at this now, we technically have a different equation to deal with, and we're restarting the problem. What's the very first thing I should do in a limit problem, Lay, now that we have a new problem in front of us? It's one of them, but it's every time I ask this question, it's always going to be the same answer. Direct sub. Let's try it. And if it works, awesome. If it doesn't, we'd have to try something else. Okay, so let's try direct sub. What would it give us? 3 times is 6, and that'd be over nothing, right? Because there's nothing in the denominator anymore. What would this allegedly be? 18. Notice, the second we do the direct sub, the limit symbol disappears. Not until then, but it's gone. Okay, we have done our limit. Because our original point was undefined, that 0 over 0, or indeterminate is what we'll actually say, we needed to find a new way to do it, but we did it, and we're still getting really close to it without actually hitting that point because we removed it. Okay, seems doable? Okay, so what do you think we're going to call this technique that we just did? Like, it's not sneaky. It's already written up there, I think. Factor. Try to factor if you can't direct sub. Okay, so right now we have 2 steps that we try. Step 1 is direct sub. If it doesn't work, what's our next option? Factor. Let's try to rewrite. So we get one more little weird algebra trick, and I'm going to have an example of each of these. And we have direct sub on the first one, piece of cake. We don't even really need to use the properties. That was just a nice review. Sometimes we have to factor stuff. And then sometimes, and I don't know why I started in the middle of this, but here we are. On C, let's get one more weird one. Okay, I want the limit as x approaches, it's not substitution. Why? What's wrong with substitution? All right, well, you guys have asked for it. You guys hear something? Okay, so I'm going to push you to the limit. This is a weird one. That's your hint. I'm going to give you like 2 minutes to play around with this. Try things. Do you guys want whiteboards to try in your small groups so you can just do them at your small groups and not worry about erasing? Would you like me to give you some small whiteboards to think out ideas so you don't have to write on your paper while you're thinking? Okay, cool. So 2 minutes. So here we are, you guys. I don't think anybody, maybe somebody got to the end, but I didn't hear it. Before we do anything weird, what is really the first thing we should try? Okay, so if I do that up top, I get root 5 minus 5, which is not 0, but it's something. Okay, no problem. What about the denominator? Ah, shucks. Is this defined here? So we need to find a function. We need to do something, right? Now, just like last time, we get to do something rather. In this situation, we can always try this. It won't necessarily always work, but it's an option. We will rationalize the numerator. And that's a weird idea because every other time in your math careers that you've ever rationalized anything, we've always just kind of said, hey, rationalize the denominator. We don't keep any square roots in the denominator. There's no real rhyme or reason to that other than, one, it makes it so that we all have the same stuff like the unit circle so that there's no confusion with what we're talking about. But it also allows us to start developing the skills to do things like this. So let's think back. If I wanted this to not be rational anymore, I can only multiply by a clever choice of what number? 1. So because of where I wrote that, and I assume that you guys wrote it in the same spot, I'll go down below. Have we plugged in a limit yet? Have we done a limit yet? Like, have we plugged in a number anywhere? No, so have to have the limit still. The limit as x approaches 5. And this is just kind of tedious, but I'll try to avoid this in the future. I'm just writing what we had originally. Okay, I need a choice of 1 that I can multiply by so that it changes the way it looks, but it doesn't really change what the value is. How do I rationalize this thing? What undoes a root x minus 5? Love it. Root x plus 5. Okay, there's a word that we use for that. We're using the conjugate. Okay, root x plus 5. What about my denominator? Root x plus 5. And I'm going to not distribute out the denominator. If I try to do it, please stop me, because every year I say this, and every year I still keep trying to do it. I hate that that's green. All right, we're going to make them match. Okay, help me out here. In the numerator, we still have our limit. We haven't done anything yet. What do we get? X minus 25. And if you're looking at that going, what? X plus 5 root x minus 5 root x, they're gone, minus 25. Okay, the denominator, we are not going to FOIL it, despite my biggest efforts. X minus 5 times root x plus 5. If we have to FOIL it, we will, but I'm going to always hold off. Okay, when we do this, how's it feeling? What did we do? Did we do anything meaningful yet? And I made a huge mistake, so we're going to fix it right now. I forgot one symbol. Can you guys tell this isn't going to work yet? If I plug in a 5, what do I still get in the denominator? It's because I had a typo. So we're going to make this really obnoxiously clear that I had a typo. It wasn't x minus 5 necessarily. It was root x minus root 5. So I'm going to fix this in these lines, and I'm only going to have to make one little change at the bottom. This would have been root x. What's the conjugate of root x minus root 5? Root x plus root 5. Okay, I wrote down the problem wrong from the get-go. That is my bad. It was supposed to be root x minus root 5, so I've added the root in everywhere. Okay, this last line is broken now, though. So let's check. This time, when we FOIL it out, only one little change. Instead of x minus 25, what does this give me? X minus 5. So terribly sorry about that, guys, but I'm glad that nobody's like revolting. Okay, the denominator, I'm still not going to FOIL it out unless I have to. I just have an x minus 5 times what? Root x plus root 5. Okay, now things feel okay. Why? You got it. I know what you're trying to say. You got it. What do the factors do? Oh, okay. All right. They cancel, sure. They divide out. I'm okay with cancel. I'm not really, but I'm going to pretend like I am. Okay. We now have a new function that we're finding the limit of that agrees at every point except the one that broke it before, which means we're essentially back to a new problem. What's the first thing I do? Let's try it. If I direct sub a x for 5 in the numerator, like, is there any x in the numerator anymore? So what's still there? 1. That's a limit of a constant. We're just using that property. Okay, the denominator becomes root 5 plus root 5. What's root 5 plus root 5? Thank you for not saying root 10. Those of you that were thinking root 10, I get it. I know why you're thinking it. 2 root 5. Is this undefined? We're done. We're good. This is the value. We don't need to approximate it. We don't need to rationalize it again. We stop here. If you get a number that's not undefined. So that didn't seem very satisfying there. But check it out. Do you want to use the 89? Just kidding. I don't have an 89 in front of me. Either I can, you're good. You can use it for now. You're good. Okay, we can either use that or we can use Desmos. Just to check this. Which do you prefer? Okay. Type in root x minus root 5 over x minus 5 as your function. And y equals. And we're not just going to do the limit. We're going to look at the graph. I'm going to pull it up on Desmos while you guys are typing that in. Bazinga. Okay. Looking at these. We have 3 approaches at this point. What's the first approach, Davian, we should always try? Direct substitution. Aisha, if direct sub fails, give me another option we can try. Factor. Factor, see if stuff divides out. Christina, if direct sub failed, factoring failed, what's this last technique we can try? Rationalizing the numerator. Okay. We have 2 routes we can take, and I don't really care which one we go. I can either give you some stuff to work on right now so that you get practice with these limits, or you can add a little tiny bit more and finish the section. Okay. So I'm not going to give you 25 minutes for homework, just so you know, but I'm going to give you about 10 minutes. Here's the rule. Your homework is going to say, expand these out, show me that you can use all the properties. What I want you to do is not expand them out all the way. You don't have to expand them at all. Don't use your calculators. I want you just to solve limits the way we've been doing it in here. Direct sub it. What I mean by not all the way, on that very first example we did, we tried direct sub and it worked right away. If it works right away, do it. I do not need to see you doing this for every single problem. Okay? All right. So we'll go for about 15 minutes, and then I think the last 10 minutes we'll get a head start or finish, and then have some time at the start of class tomorrow. But we're going to start our assignment first. So for this evening, and let's see, it is the 26th. You guys get the privilege of homework 1.2. I'll just say it 1.2 with the understanding that I'm going to add problems tomorrow. You will find this on page 100. I don't know why I did that. 1.2, page 100. And let's see here. I have 35 through 40. Okay, 35 through 47 odd, 48, and 51 through 59 odd. Okay, I'm not going to put a due date on this because I guarantee I add problems tomorrow. I'm going to give us about 15 minutes right now to get started on it. I'm here to answer questions and stuff, but then we'll use the last 10 minutes to get a head start on tomorrow's stuff. Cool.